Today I'm going to be going through part 1 of the October 2025 maths paper for International Edexcel. And chances are, if you can't get through these 3 questions in the beginning, you'll find the rest of the paper extremely challenging. That's because these 3 concepts are part of the testing of your core fundamental skills of the entire syllabus. So with that in mind, make sure to stick to the end so you can get a full understanding of all 3. And without further ado, let's jump straight into the paper. Alright guys, so for question 1, we are given 2 triangles, okay? We're told that solutions relying on technology using a calculator is unacceptable. So okay, fine. So we've got 2 triangles. We've got an equilateral triangle over here, and we have a right angle triangle over here. It says that triangle LMN is equilateral with sides x plus 7, okay? So therefore what we can do here is quickly just say we've got x plus 7 there and x plus 7 there as well. And then it says that triangle PQR is a right-angled isosceles, okay, with triangle PQ equals PR equals 2x, an angle of 90 degrees. It says to, for number A, find in its simplest form, in terms of x, the length QR. So we need to find this. Now this is a very easy question, because all you need to do is deploy the Pythagorean theorem. All we're going to say, guys, scroll down to the answer sheet. All we're going to say for this one is I'm going to say that QR squared, okay, is going to equal to 2x squared plus 2x squared, okay? So therefore QR squared is equal to 2 times 2x squared, which is equal to 2 4x squared, okay? And as a result, from there, what we're going to get is 8x squared, okay? So therefore QR squared is equal to 8x squared. So QR is going to equal to the root of 8x squared, and that's going to equal 4 times 2 times x squared, which equals 4 times root 2 times root x squared, which equals 2 root 2 x units, okay? So that's going to be the final answer. As you can see, it was quite easy, but there was a little twist there. We weren't allowed to use a calculator. Now why is that? Well, let me finish 1b and we'll go into the whole thing all together. Alright guys, so for 1b, it says that given the perimeter of the triangle LMN, okay, this thing over here, is equal to the perimeter of the triangle PQR, it tells us to find the value of x, okay, and write it in the form a root 2 plus b, okay, and a and b are integers. Cool. So that means a and b cannot be fractions. Important point there. So what I'm going to say in this case, for 1b, we're going to set this up. The perimeters must be equal, okay? So our first perimeter, okay, which was for LMN, that's going to equal to 3x plus 7. Okay, which equals 3x plus 21. Technically it's units, but just for keeping it simple now, I don't want to be adding units to the end of everything. Next thing you know, our second perimeter, QPR, that's going to equal 2 times 2x, okay, plus 2 root 2 x, okay, because we just found this from before. Okay, so now we've got 2 perimeters, here and here, and we know that they're equal. So what I'm going to say is, okay, therefore 3x plus 21 is going to equal to 4x plus 2 root 2x. Okay? Brilliant. So the next thing I'm going to do is say, well, 21 then, that's going to equal x. Okay? And then we've got 2 root 2x over here. Okay, x plus 2 root 2x. Then I'm going to say, well, 21, take out the x, we get 1 plus 2 root 2. So as a result, x is going to equal 21 over 1 plus 2 root 2. Okay. Now what I'm going to do now is I'm going to rationalize the denominator. 1 minus 2 root 2 over 1 minus 2 root 2. So x then is going to equal 21 1 minus 2 root 2. Okay. Over 1 minus 2 root 2 squared. Okay. So I can therefore say that x is going to equal 21 1 minus 2 root 2 over negative 7. Which means from here that x is going to equal negative 3 1 minus 2 root 2. Okay. Which means that x is going to equal negative 3 plus 6 root 2 units. Okay. Or actually not the units, we don't need that, I don't think. Value of x, yeah, we're fine. So x is going to equal negative 3 plus 6 root 2 there. Alright guys, so as you can tell, that first question was actually pretty easy, okay? Now, you're probably thinking to yourself, well, why was it so easy? Like, what was the thing they're actually testing there? Because obviously, to have a question that simply wants you to find, QR here by using the Pythagoras theorem, that's quite easy. That's at GCSE level. So what are they actually testing? Well, the devil's in the details, because as you can see in this question, they said explicitly that solutions relying on calculator technology are not acceptable. Okay, so what were they testing? They were testing surds. That's what they were testing. Okay, so as you can tell from 1A, okay, in 1A, yes, okay, we found QR pretty easily. That was 8x squared, and obviously with a calculator you could have simplified that down, but we weren't allowed to use a calculator, so therefore we had to use our surd knowledge. Okay, so what we said here is we said root 8x squared. Okay, we broke that down into 4 times 2 times x squared. Why have I done that? Because when you break down a number into its products within a root, okay, we can then take those products out of the root and they become their own independent roots. Hence why in this situation, when we had 4 times 2 times x squared, we could break that down into root 4 times root 2 times root x squared. Okay, and that was the key here. And when we did that, we were then able to simplify it, because obviously root 4 is 2, then we have root 2, and then root x is obviously root x squared is obviously x. Okay, so we got 2 root x units from that. For number 1b, this was a similar situation, right? It wasn't that difficult off the face of it. Again, it was a GCSE type question where we simply know, okay, the perimeter of a triangle, we just add up the sides and we set it equal. Find x. Cool. Again, they're testing your surd knowledge, but different type of surd knowledge here. In this scenario, they made it very clear, as you can see from the question, that they wanted it in the form of a root 2 plus b, okay, where a and b must be integers. So what does that mean for us? Well, what that means for us, okay, is when we're simplifying this, we had to, by virtue of that, say, well, listen, we got 21 is equal to 1 plus 2 root 2 times x, okay? Because again, we factorized x plus 2 root 2x. So we get 21 is equal to 1 plus 2 root 2x, okay? So we say x, well, that's going to equal 21 over 1 plus 2 root 2. Now, obviously, with a lot of people, they're going to get stuck at this bit because they're going to say, well, look, what do I do from here? I obviously can't get it in the form they want, so I'm stuck. What do I do? Well, this is where we rationalize the denominator, okay? And that's the principle that basically says that whenever you have a denominator like this, okay, it could be algebraic, it could be just a normal number here, like 1 plus 2 root 2. We can rationalize it by essentially timesing it by its conjugate, okay, over itself. Okay, so in this case, we had 1 plus 2 root 2 at the bottom. Okay, so therefore by multiplying it by 1 minus 2 root 2 over 1 minus 2 root 2, we are able then to break it down into a much more simplified form. Okay, and this is true because, again, remember, 1 minus 2 root 2 over 1 minus 2 root 2 simply equals 1. So this is perfectly reasonable to say. But the effect this has is that we get the difference of two squares at the bottom, okay, which in this case breaks us down into an easy number to work with, which is negative 7. Okay, and obviously 21 is going to be multiplied by 1 minus 2 root 2 now. And as a result, we get 21 over minus 7, gives us minus 3. And then we can multiply the minus 3 in, which again, obviously made things way easier for us. So guys, if you are struggling with Edexcel Maths, make sure to click the link below to join the waiting list for our community. One of our students from there, they were working in the community and they got 100% in a worksheet that was assigned to them by their school. So obviously you've seen good results. So if you're keen and you're struggling and you don't know where to start when it comes to maths and studying for exams, make sure to join that wait list. Alright guys, so for number 2, we're told, again, we cannot rely on a calculator, but we have a curve which equals this, and we need to find in its simplest form dy by dx. Okay, that's for number 2a. So if we do that now, for number 2a, what we have here is y is equal to x times x plus 3 times x minus 2, which means that y is equal to x squared minus 2x plus 3x minus 6, which means that y is equal to x cubed. Actually, I'm not going to do that bit yet. I'm going to simplify it. X squared plus x minus 6. Okay, yep, which means that y x cubed plus x squared minus 6x, which means that dy by dx is therefore going to equal 3x squared plus 2x minus 6. Okay. Alright guys, so for 2b, we are told to find the values of x, okay, for which dy by dx is greater than or equal to 0. Okay, so the way we're going to do this is we're going to say to ourselves, look, dy by dx must be greater than or equal to 2. Okay, cool. So what am I going to say here? Well, what's dy by dx? Well, dy by dx is this because we just solved for it. So therefore I'm going to say 3x squared plus 2x minus 6, that's going to be greater than 2. Okay, but now we've got an issue. Well, how do we solve it from here? Well, we're simply going to take the 2 because it's an inequality to the other side. So that's going to equal 3x squared plus 2x minus 8 must be greater than or equal to 0. Okay. Next, remember, they didn't want us using a calculator for this, so we need to ask ourselves, so like, how do we solve from here? Like, what do we do? Well, what we're going to do, guys, is we're going to times the 3 times minus 8, which gives us a negative 24. Because then we can break that negative 24 into 6 times a negative 4, which also its sum gives us 2. So as a result, we get 3x squared plus 6x minus 4x minus 8 must be greater than or equal to 0. Okay? Which means that if we take out 3x, we've got 3x times x minus 2 minus 4. That's going to be x plus 2, sorry, minus 4, x plus 2. That's all going to be bigger than 0. So therefore we get 3x minus 4 times x plus 2 is greater than or equal to 0. So as a result, guys, if we were to simply say now, we let it equal 0. Okay. X equals 4 over 3, or x equals minus 2. And so if we draw this on a parabola, okay, we've got 4 over 3 here, we got minus 2 here. Draw a parabola, we know it must be greater than 0, so when's it going to be greater than 0? It's going to be greater than 0 to the right of 4 over 3 and to the left of minus 2. So as a result, we can simply say, therefore x must be greater than 4 over 3, or x must be smaller than or equal to minus 2. Okay, and that's going to be the final answer to number 2b, guys. Okay guys, so for number 2, let's take a look at 2a, okay? So 2a, what were they really trying to test here? Again, no calculator technology acceptable. So simplest form, dy by dx. This was a bit of a tee-up question. I'm actually surprised they put this in, because it's actually pretty easy. But, we'll take it, So they obviously put it into brackets here to make it easy to multiply out. Not easy, sorry, a bit more of a mission to multiply out. All we have to do here to find dy by dx is multiply it out, okay, to get y, okay, which we got as x cubed plus x squared minus 6x. And what they were trying to test here is, do they know how to find dy by dx? Which in our case we do. It's very simple. We simply take the 3 down. Okay, because remember our dy by dx method, whenever we have an algebraic expression, we're going to take the exponent down, multiply it by our variable, and then we're going to minus 1 from our exponent, okay? So that's all we've done here, just for x cubed plus x squared minus 6x, okay? So we've done that for each of the elements of our expression here, so therefore we get 3x squared plus 2x minus 6 as dy by dx. Again, a bit more on the easy side this one. But they were trying to test, okay, do they know how to expand brackets with our calculator? Pretty simple. And then, do they know the actual process of finding the derivative? Alright guys, so for 2b, they were trying to test, do we know how to find the values of x such that dy by dx is always greater than or equal to 2? Okay, so again, no calculator allowed here, so what were they trying to do? Well, this was 2 things. They were testing our inequalities knowledge and also our factorization knowledge. Okay, so the key thing here was we need to say, okay, we got dy by dx, and we're going to set that bigger than or equal to 2. Once we do that, we can then say, well, okay, take the 2 over, so we have 3x squared plus 2x minus 8 must be greater than or equal to 0. Okay, now from here, this is probably where they're trying to catch people out, because again, you weren't allowed a calculator, so you need to factorize this manually. So some people who maybe haven't brushed up on their algebra would have struggled here. All we did here, we multiplied 3 times negative 8, which gives us negative 24. As a result, we know that negative 24 can be broken down into 6 times negative 4, okay? And at the same time, 6 times negative 4, 6 plus negative 4, is equal to 6 minus 4, which equals 2. Okay, so that 2x now, well, we're going to break this all down. We're going to say that 3x squared plus 6x minus 4x minus 8 must be bigger than or equal to 0. Okay, and as a result, we now factorize. We get 3x times the common factor x plus 2 minus 4 times the common factor x plus 2 is greater than or equal to 0, which means that 3x minus 4 times x plus 2 must be greater than or equal to 0. But we're not done yet, because the next part is again testing, do they know how to actually manage these inequalities in the final stages? And we do. We showed that, because we drew a parabola and we said, look, we know that it intersects the x-axis here at 4 for 3 and x equals minus 2. So as a result, once we draw a parabola, we can clearly see that we are only greater than 0. Our function is only greater than 0 post 4 over 3 and before negative 2. So as a result, our values here were x is greater than or equal to 4 over 3, or x is smaller than or equal to negative 2. In a different scenario, if they wanted it to be equal, okay, dy by dx is equal to 2, we would have made these equal signs. If it was smaller than, we would have had a situation where we would have been in between negative 2 and 4 over 3. Okay, so that's what they're trying to test, just your understanding of inequalities. Alright guys, now for number 3, similar to before, we can't use any calculator technology, but it wants us to solve this equation. Okay, 2y squared plus 1 is equal to 15 over y squared. Okay, so let's get into that. Okay, so 2y plus 1 is equal to 15 over y squared. Okay, first thing I'm going to do is I'm actually going to times the y squared over to the other side. So therefore we get 2, we get 2 y to the 4, okay, so y squared is equal to 15, which means therefore 2y4, okay, plus y squared minus 15 is equal to 0. Okay, I'm then going to say that k equal y squared, which means that therefore we get 2k squared, k plus k minus 15 is equal to 0. 2 times minus 15 is equal to negative 30, which can be broken down into 6 times 5. Okay, but we need some negative 30, so I'm going to do 6 times minus 5, and then 6. The sum of 6 and minus 5 is 1, which corresponds to our 1k here. So therefore we get 2k squared, okay, plus 6k minus 5k minus 15 is equal to 0. Okay, so I can take out a 2k here to get k plus 3 minus 5. K plus 3 is equal to 0. So therefore 2k minus 5. K plus 3 is equal to 0. Okay, so therefore 2k equals 5, k is equal to 5 over 2, or k equals minus 3. But now we're going to sub back in, so therefore we're going to say y squared now is going to equal 5 over 2, or y squared is equal to minus 3. I'm going to say no real solutions here, okay, because y, that's a negative. Okay, I'm going to say y is going to equal plus minus 5 over 2 as our final answer here, guys. Alright guys, so for question 3, what they were trying to test here now was, okay, we're given a an equation, 2y squared plus 1 is equal to 15 over y squared. And when we multiply out, we get 2y to the power 4 plus y squared is equal to 15. So again, what they were testing was your quadratics knowledge. Specifically, do they know how to solve an equation when we're not given just a typical x squared? What do they do? How do they adapt? And we showed them that we do, because all we did here, and this is all you need to do for all types of scenarios, when you have y to the 4, or let's say x to the half, we're going to use a k substitution to make things easier for ourselves. Okay, so in this scenario, we let k equal y squared, and that allowed us to solve this like a normal quadratic. And when we did, using methods previously explained, we get 2k minus 5 times k plus 3 is equal to 0, which means then that k is equal to 5 over 2, or k is equal to negative 3. But we're not done yet, because y squared, we're going to resub that in, which means that y squared is equal to 5 over 2, or y squared is equal to negative 3. But remember, y squared can't equal minus 3 within the scope of the syllabus, so we're going to have no real solutions there. But meanwhile, y is going to equal plus minus root 5 over 2. Okay, so the key thing they were testing there was, do they get scared once we give them a variable to the power 4? Okay, do they know how to solve that equation? And the same thing could be said if they give you, say, y to the power of half. In this scenario, again, we're going to use a substitution to then solve, for k in this instance, and then resub in. So that's where they try to catch you out. And the key thing here is to recognize, how can I recognize and ask yourself, how can I convert this into some kind of quadratic equation? And you do that via substitution. Okay? And then that allows you to solve things a lot easier.